Okay, I am going to go over build a concept with you really quick because it's going to show you something that I think you guys will understand a little bit better. So I wrote out all the ratios first, y to x, all right? So 2 to 1, 3 to 3, 5 to 4, 5 to 7, 6 to 9, all right? So if I took these ratios and I tried to determine whether or not they had a proportional relationship, I would first have to see if I could reduce them, okay? And then I have to graph the ordered pairs on the coordinate plane, which I actually did already for you, all right? So I took all of these ordered pairs, so y is 2, x is 1, and I plotted it. And I went and I did that for all of them. And if you notice, this forms a straight line, right? So if the points form a straight line that passes through the origin, meaning right here, okay? Because if this was a true coordinate, if this was the whole coordinate plane, not just coordinate 1, the origin, if you remember, is in the center, all right? So if the points form a straight line that passes through the origin, x and y are proportional. So if this line went all the way through here, it would be proportional. But does it pass through the origin? It does not pass through the origin. Do the points form a straight line? Yes, they do. They do not pass through the origin, so they do not have a proportional relationship. So another way to kind of explain that to you is, oh, my stand's gonna fall. If I took all of these and I reduced them, okay, I reduced the ratios. So 2 over 1's already reduced, so that's just 2 over 1. So I guess I could write that again for you. 3 over 3 would be 1 whole, but I'm not gonna change that. 4 over 5 can't be reduced. 5 over 7 can't be reduced. That's already in simplest form. 6 over 9. Oh, that can be reduced. Greatest common factor would be 3. Okay. And so that could be 2 to 3. Okay. So they really don't have anything in common, do they? They don't really share a common thing. I mean, this does. My 2 numerators are 2, but it does the rest of them, and this one 3, but the rest of them they do not. And also when you look back here, they do not pass through the origin. So they do not form a proportional relationship. All right. So if we go to try it together real quick and we go to number 4, let's look at this table. Okay. Directions say determine whether x and y are in a proportional relationship. If x and y form a proportional relationship, we're going to write the equation. All right. So ratio of y to x. So y to x. 6 over 4, 15 over 10, 18 over 12. Okay. The only thing that's different about this is they only give you 1 box. So you have to write the ratios in simplest form, okay? Which is why it's really important to kind of have another sheet of paper ready for your work, okay? Because if you did 6 to 4, sorry, Jake is growling at something, you would have to find my greatest common factor. In this instance, it's 2, and it would be 3 to 2.
There's a bird nest there.
3 to 2. 15 to 10. Greatest common factor is 5. 3 to 2. Right? And you would go all the way here. Right? And you would keep on reducing those ratios. So for time's sake, I am just going to go ahead and I'm going to hurry up and just place these in their reduced form. Okay? What do you notice here about these ratios? Okay. The ratio is y to x for the first pair. All right. 3 to 2, 3 to 2. It's looking pretty good for so far. 3 to 2, looking pretty good. 4 to 3, 1 to 2. Uh-oh. All right, so you notice some differences here, right? So, are all the ratios the same? Nope, no they are not. So, can the relationship between x and y be proportional? No, they cannot, because these ratios, when they are reduced, are not the same. All right, so we would say no. All right, so let's go ahead and do this one, okay? Because number 5 is, it throws us for a loop because, oh my goodness, it has a fraction in it, okay? Don't be scared, don't worry. So if I go to number 5, all right, what is the ratio of y to x for the first pair of values written as a fraction? So 4/5 over 2, okay? So what that really means, boys and girls, is that I am going to what? I am going to divide this fraction by this whole number. And I know you guys know how to do that. You got to pull it way back from your memory, but you know how to do that. All right, and I'm going to show you right now how to do that. All right, so if I am going to reduce this, okay, so 4/5 divided by 2, or 2 over 1, okay, what I would really have to do is I would have to do what? Keep it, change it, and multiply by the reciprocal, right? Which would be 4/10. If I had to reduce 4/10, what would that be? Well, I know my greatest common factor would have to be 2, which would be 2 over 5, okay? So that first one right here, although it's a fraction, don't let it scare you, okay? Because you know how to divide fractions. You did a fantastic job in that. So it's just realizing what it's asking you to do and then actually executing it. So 2/5. 2/5. 2 to 5. This one's the same. 2 to 5. If I did 8 to 20 and I reduce that, it would also be 2 to 5. This one would also be 2 to 5. So, do x and y form a proportional relationship? Yes, they do, because, well, do they all reduce to the same ratio? Yes, they do. Okay? 2 to 5. Okay. I want you to read the how-to. Okay, this is a great how-to. It says for each pair of values, you're going to write the ratio of y to x as a fraction in simplest form. If the ratios are all the same, can you see that? I'm not really sure if you can. If the ratios are all the same, x and y, they are in a proportional relationship. Use the ratio to write an expression or an equation that describes the relationship. And when they say that, they mean this, y equals 1/2 x for this example. Okay, just like for this one, y equals 2/5 x. All right. So for your assignment, I am just going to have you guys do 6, 7, 8, 9, and 10. All right. I'm also going to have you do the problem solving because it is a great practice problem that gives you the y and the x values, and then it has you graph the equation. Okay. I will post the answer key for you guys so you can check your work. And you know what? I will also post the checkup for you to hand into me with the answer key so you guys can check your work, make sure you're on the right track. All right. And as always, you guys have any problems or you run into some confusion or you're just like, Mrs. Collier, I have no idea what you're talking about. Please help me. Guess where I'm at? I'm at home. So you can call me anytime. Got it? Day or night. All right. I'll see you guys later. Bye.